Hello, good day. Welcome to the first tutorial. Today we'll be doing 2024 WAEC practical. So let's take a look at the question that we have. Using the spring balance provided, determine the weight of the object of mass m is equal to 100 grams. So we call this weight as W1. Determine the weight of the object when it is completely immersed in water contained in a beaker, as shown in the diagram. We call the label as W2. Determine the weight of the object when it is completely immersed in the liquid labeled L. Record the weight as W3. So we are asked to evaluate U, which is called to W1 and W2. Repeat the procedure with the object of masses 200, 300, 400, and 500 grams. In each case, evaluate U equal to W1 and W2 and V equal to W1 and W3. Tabulate your readings. Plot a graph of V equal to W1 and W3 on the vertical axis against U, which is equal to W1 and W2 on the horizontal axis. Determine the slope S of the graph. Number 7. Evaluate K, which is equal to 100 S. State the precautions you took to ensure accurate results, and then the forces acting on the body immersed in the fluid, and the questions that follow. So if you are just joining us in the LFS tutorial, you're welcome. Make sure you subscribe, hit the subscribe button, turn on your notification bell, and then a like. You can share the video to your friends or to anyone you know that is preparing for 2024 WAEC practical physics. So we have a string balance provided. The weight of the object is 100 grams, and then they expect us to have a particular diagram like this, and then we have the spring balance. And then after this, we have something like a thread attached to it and a mass of 100 grams. So it is first weighed. When it is weighed, we have the weight in air, WA, and when it is weighed, since we have 100 gram weight, so we'll calculate the weight of 100 gram. We'll put it here. That's when it is weighed. So the next thing is, this mass is immersed in a beaker, and the beaker contains water. It is with water like this, and then when we call the weight again as the weight in water, so that's our W. And then the next thing is, this beaker is replaced with another beaker which contains a liquid L. So in this case, you are getting kerosene. So that will be weight in liquid. So we are asked to set a tabular form. So in this tabular form, we have the weight in air. So we have the weight in liquid. Don't forget, our weight in air is what we have as W1. That's our weight in air, which is equal to W1. So we use W1. And then the next thing that we have is our weight in water. The weight in water is recorded as W2. We call the weight as W2 when it is immersed in water. And then that's weight in water, W2. And then we also have the weight in the liquid L, and that's what our W3. This is the weight in liquid L. Remember I told you that the liquid we have here is what? Is kerosene. And then after that, we are asked to do some arithmetic. We have U equal to W1 minus W2. W1 minus W2. And then we are also asked to find B equal to W1 minus W3. W1 minus W3. So we are asked to find U, which is equal to this, and then we also have to find V, which is equal to this. Now let's do the practical. Since the first mass that we have is 100 grams, if our first mass is 100 grams, don't forget we are going to. So we are back to the lab. So we have our mass here. So we are going to put the mass in our balance. Don't forget, this balance that we are using for this practical is graduated in gram. So and what we need is the weight of this mass, which should be in Newton. So by the time I lower it, I see that the mass that I have here is 100 gram. Then I will move it. So the weight in air when there is nothing inside is 100 gram. But our weight must always be in Newton. So we are going to convert this 100 gram to a weight of Newton. So the mass M1 is 100 gram. Once we divide by 1000, we have 0.1 kg. We have divided the mass to 0.1 kg. So 0.1 kg, since our weight is equal to mass multiplied by gravity, so the weight is equal to 0.1 multiplied by gravity, which is 10. That means the weight is equal to 1 Newton. It means that 100 gram is equivalent to 1 Newton. So what we have here is 1 Newton. We don't need to put Newton here again because we already have Newton at the top. So we have 1. So the next thing we are going to do is this same mass, we are going to hang it back to the thread. We hang it back, and then after that, we gently lower it into the beaker of water, gently, and see what we have. Gently, gently. Make sure it's not touching the sides of the beaker and it's not touching the bottom. So when we check it, what we have here is this is not 100 grams, this is 90 grams. 90 grams. So once we have 90 grams, we have our 90 grams. 90 grams. 90 grams divided by 1000, that's 0.09 kilogram. Then we multiply by 10 as we have been doing. The weight is equal to mg. 0.09 multiplied by 10, that's 0.9 Newton. So if the weight in air is 1 Newton, while in mass in water, our weight becomes 0.9 Newton. As you can see, when an object is immersed in water, there is a loss in weight. It becomes light. We have 0.9 Newton. Now, let's see when we immerse it into liquid air that we have here, which is kerosene. When we gently immerse it, don't forget, it must not touch the side of the beaker or the bottom of the beaker. Let's gently immerse it and see what we have. Gently. When we look at what we have here, it is close. This is 95. That's 95. So you remove it. So we have 95. 95. So come here, we have 95 grams. 95 grams. 95 grams divided by 1000, that's 0.095. 0.095. Then multiply by 10, that's 0.95. So we have 0.95 Newton. 0.95 Newton. So we have the first mass, which weight is 1 Newton, a mass in water, we have 0.9 Newton, and then when we put it inside kerosene, which is the liquid air, we have 0.95 Newton. So according to the question, we are going to have another mass again, which is 200 grams. So in this case, we have 200 grams, 100 grams, 100 grams. So I'm going to put the two together at the same time. So this is 100 grams, and then this is also another 100 grams. So putting the two together at the same time, and when I check, I have my two. So I have my 200 grams. So don't forget that 200 grams divided by 1000 will be equivalent to 0.2 kg. And if I multiply by 10, that's equivalent to 2 Newton. So what I have here is 2 Newton. So let's immerse this into water. Let's immerse it into water. When we do that, let's see what we have. 2 Newton. Lower it gently. Must not touch the side of the bottom. Let's take our reading. As you see, we have this is 100, 110, 140, 100, 140, no 100, 120, 140, 160. This is 160. 100, 120, 140, 160. This is 160. So what we have here is 160 gram. We divide by 1000, 1, 2, 3. That's 0.16. Then by the time we multiply by 10, that's 1.6. So we have 1.6 Newton in water. 1.6 Newton in water. So the next thing is let's see what it weighs in kerosene. What it weighs in kerosene. So I would like to clean the masses. And then we'll put it again back inside kerosene. So we have our masses here. Okay, and then we'll release it gently inside the liquid L that we have here. Pour it gently inside the liquid L. It must not touch the side of the beaker, don't forget, or the bottom of the beaker. And then we carefully take our reading. So this is 100, 120, 140, 160. This is 180. 180. So we can remove it. That's 180 grams. So you convert the 180 gram into kilogram. That's what we are going to divide by 1000. So that's 0.18. Multiply by 10. That's 1.8. So I have 1.8 Newton. So 1.8 Newton. Don't forget that you will notice a particular pattern in water. It is 0.9 Newton, but in kerosene the mass is a little bit, the weight is a bit high, 0.95 Newton. In water here it is 1.6 Newton, but while the mass in kerosene is also higher, 1.8 Newton. So the next thing that we have is a mass which is equivalent to 300 gram. If you have 300 gram, what are we going to get? 300 gram. So we have our mass 1, 2, little mass, and then third one. Next thing we have is a mass of 300 grams immersed in the water. So we are going to have 100, 200, 220, 240, 250. That's 250 grams. So our 250 grams will give us 0.25 kilogram, and that's 2.5 Newton. 2.5 Newton. So the next thing is you are going to also immerse this in our liquid L. So I would like to clean the masses before we put it inside the liquid. Clean the mass, and then we now immerse in our liquid L. Gently, then we put inside the liquid L, pour it gently, and then we read. So we have 100, 200, 220, 240, 260. So this is 260 grams. So 260 grams will be going to 2.6. So from here we have 2.6 Newton. 2.6 Newton. So the next thing that we're going to have is when we have 4 masses. That is 4 Newton. 4 masses, which is equivalent to what? 4 Newton. That's 400 grams. So we are going to immerse these 4 masses in water. Don't forget, just to wipe the body off before we put it inside water. We are going to immerse in water. So we put our water and we immerse in water. So these are 3 masses. Please don't forget you have to add 1 more. You are going to 4 Newton. So this is our 4 masses. 4. 1, 2, 3, 4. Then we must attach to the spring balance. And then we gently immerse in water. So it's not covering the entire liquid. So let me lift it up and see what I have. So why is I have this is 200, 100, 200, 300, 320, 340. So this is 340, 100, 200, 300, 340. Why it is in math is 340. So you can remove it. And then 340 gram is equivalent to 3.4 Newton. 3.4 Newton. That's when it is immersed in water. So the next thing is we are also going to immerse it inside the liquid air as our kerosene. So cleaning the mass again. So once we clean the mass, we have our liquid air here. Then we attach again. Prepare this. Now we have here. We have 100, 200, 300, 320, 340, 360. So this is 360. 360, 300, 320, 340, 360. This is 360. While immersed in the liquid air. So 360 gram, which is equal to 3.6 Newton. 3.6 Newton. So and the last one is our 5 Newton, which is 500 gram. 5 Newton is 500 gram. So we don't have any other additional 100 gram, but we can add 250 grams. So we have 150 gram, we have another 50 gram attached. So we are going to clean it as what we begin, and then we immerse this inside the beaker of water. So immersing in the beaker of water, we have this beaker of water. Don't forget it must not touch what's it called? The sides of the beaker. So I would like to begin to get total immersion. Oh, it's not submerging. So it's not submerging for 500. So I will change the beaker now so that I can have the masses fully submerged. You can have that. Let's see. We have the beaker of water and then a mass of 500 gram, which is 5 Newton. We then place it. And then we'll see what we have. Don't forget our mass is not entering this water in full, so I will gently lift it up to see total submersion. Then you can see what I have here. I have 100, 200, 300, 400, 420, 430. This is 430, total immersion. 430 this is 4.3 Newton. 4.3 Newton. So I have 4.3 Newton here while immersed in water. And lastly, we are going to immerse this same mass in liquid air that we are given. So we are going to immerse in liquid air that we are given. So doing that, we have the masses
and on the screen balance position. This time around we place it inside the inside the liquid L. We are not having enough liquid L now, so you can add a little to the liquid. So we are having more, and now we are going to immerse. Don't forget, it's a full immersion, not a partial immersion. The whole mass must be submerged in the liquid L. A full immersion. So we have this. And do this. Okay. We have 400, 420, 440, 460. This 460. 460. So that's 460. That's 4.6. So what we have here is 4.6 Newton. Okay. Thank you. You see that so far when we are weighting air is 1 Newton, we have the weight in water to be 0.9 Newton and the weight in the liquid L to be 0.5 Newton. And then when our weight in air is 2 Newton, the weight in water is 1.6 Newton and this is 1.8 Newton. And downward, this is all what we have. Please don't forget, in your practical, you might not be given 100 gram, 200 gram, 300 gram, 400 gram as the case may be. It might be 10 gram, 20 gram, 30 gram, 40 gram, and 50 gram. It doesn't matter. But it's still the same pattern, it's still the same techniques. So let's move over to our class and then do the calculation aspect. Thank you. So our U is W1 minus W2. So what's our W1? 1 Newton minus 0.9, that's 0.1. 2 Newton minus 1.6, that's 0.4. 3 Newton minus 2.5, that's 0.5. 4 Newton minus 3.4, that's 0.6. 5 Newton minus 4.3, that's 0.7. Also W1 minus W3, so we have 0.05. We have 0.2. 3 minus 2.6, we have 0.4. 4 minus 3.6, now we got 0.4. 3 minus 2.6, 2.6, 2.7, 2.8, 2.93, 0.4. 4 minus 3.6, that's 0.4. Then 5 minus 4.6, that's also going to give me 0.4. So let's cross check. W1 minus W3 will give me 0.05. 2 minus 1.8 will give me 0.2. 3 minus 2.6 will give me 0.4. 4 minus 3.6 will give me 0.4. And 5 minus 4.6 is going to give me 0.4. So this is our values. So let's go back to the question. Evaluate U equal to W1 and W2. You have done that. Repeat the procedure with the object of masses 200, 300, 400, and 500 grams. In this case, evaluate W1 and W2, which is V, and which is U, and V to be equal to W1 and W3. We have done that. So tabulate your readings. Plot a graph of V equal to W1 and W2 on the vertical axis against U on the horizontal axis, and then we'll determine the slope of the graph. Don't forget that the slope of the graph is correlated to what we are doing, which is the relative density of the liquid. Okay, now let's plot the graph. We are asked to plot a graph of V, which is W1 and W3 on the vertical axis. So what we have here on the vertical axis, and then U on the horizontal axis. So since we have something like this, we can have from here to here is 2 centimeters, which is you can say let's a 2 centimeters represent 0.1 units. So that becomes 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and 0.8 is correct. So we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7.
So at this stage, you will see that 2 centimeters from here to here represents 0.1 units on the x-axis. 2 centimeters represents 0.1 units on the x-axis, and that's our U. Then the next thing is the vertical axis. We have 0.05, 0.2, 0.4, 0.4, 0.4. So after 0.05, you can say let this place be 0.05. Then we'll have, or this is 0.1, 0.2, 0.3, 0.4, 0.1, 0.2. Okay, let's make it 0.2, 0.1, 0.2, 0.3, 0.4. So also on the vertical axis, 2 centimeters represents 0.1 unit. So if I have 0.1 unit here, and we have 10 lines in between, 10 lines, don't forget. So 0.1 divided by 10 is going to give me 0.01. So each line here is 0.01. So this is 0.01, 0.02, 0.03, 0.04, 0.05, that's what we have here, 0.05. We are plotting it on the vertical axis with 0.1, with 0.1. So we'll stop here. We are straight it. So the next one is we are plotting 0.4 with 0.2. Don't forget 0.2 is on the vertical axis. We are plotting with 0.4. 0.4 they are meeting here. Straight it. The next one again is we are plotting 0.4 on the vertical axis with 0.5. 0.4 on the vertical axis with 0.5. But we are straight it again. Also, we are plotting 0.4 on the vertical axis with 0.6. So we also have straight it again. And then we are also plotting 0.4 on the vertical axis with 0.7. So we are striking it again. So we see our graph having something like this. This is the shape that we have. This is the shape of what we have. So determine the slope of the graph. Evaluate K to be equal to 100 multiplied by slope. So if you are calculating the slope of the graph, so we can pick to third, that's from here, or we pick from here and then to this place, all to here. So you can get the slope of the graph. So from here to here, so we read this one down, we read this down, so we can read this to 0.1, and then we also read like this. So from here, we know that our slope is equal to y2 minus y1 all over x2 minus x1. So our y2 is what we have here. This is 0.1 divided by 10. This 0.4, 0.4, 2.41, 42, 43, 44, 45, 46, 47, 48, 49, 2.5. This 0.48, 0.48 minus. So we come here again and see these are 0.2. These are x-axis. 0.48 minus 0.2. Then we check for our y-axis here. That's somewhere here. 0.3, 31, 32. This is 0.39. 0.39 minus. Then we check here 0.1. So 0.39 minus 0.29. 1 is going to give you 0.29 divided by 0.28. So 0.29 divided by 0.828 is going to give me the slope of the graph. 0.29 divided by 0.28. That is 1.0 4. So 1.04. So our K is equal to 1.04. Our X is equal to 1.04. X is equal to 1.04. So 1.04 multiplied by 100, we are going to get 104 to be the value of K. So state 2 precautions you took to ensure accurate results. Number 1, I avoided parallel error while reading the spring balance, and also number 2, I ensure that the mass does not touch the base of the beaker while attaching the mass to the spring balance. So with the aid of a label diagram, show the forces acting on the body, a mass in a fluid. So if I have a body, a mass in a fluid, the base of the diagram, how am I going to show these forces? With the aid of a diagram. Let's quickly look at that. When a body is immersed in a fluid, when the body is immersed in a fluid, the weight of the weight of the body acts downward. The weight acts downward, and there's a force exerted by the water at the bottom of the base, at the bottom of this object. That's an upward, that one act upward. So these are the forces shown acting on the body immersed in a fluid. So that is weight and upward. So the weight is acting downward while the upward is acting upward. If I use a string to attach this, the tension is also facing upward. So we see here that our tension, which is equal to weight minus upward. This is what we have here. Tension to be equal to weight minus upward. And we are asked to state Archimedes' principle, which says that when the body is partially or wholly immersed in a fluid, it experiences an upthrust, which means loss in weight, and this upthrust is equal to the weight of the fluid displaced. Let's look at the last example.